myself Sudeep Kumar Jha from the Pioneer Classes Patna. Today I have some leisure time, so want to share some topic with all of you. So in this session I am going to start the topic the chemical bonding. Before starting chemical bonding, we should know about some tool which is necessary for the chemical bonding. The first is Lewis structure or electron dot structure of an atom. Suppose we are talking about the sodium atom, which has atomic number 11 and mass number 23. In this atom, there are 11 electrons, 11 protons and 12 neutrons. The simple structure is all the protons and the neutrons lie in the nucleus of the atom, that is 11 protons and 12 neutrons lie in this nucleus, and electrons revolve around the nucleus in different orbits. In first orbit there are 2 electrons, in second orbit there are 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. In third orbit there is 1 electron. So writing in this way every time is difficult. So to ease this structure, the nucleus and the inner cells are denoted by the symbol of the element only, Na, and the electron in the outermost cell, that is valence electron, is denoted by the dot. And this is the electron dot structure of sodium atom. So simply electron dot structure is the symbol of the element with some dots which represents the valence electrons. This was electron dot structure of an atom. Now we should know about the inert gases. There are 6 inert gases. These are helium, neon, argon, krypton, xenon and radon. Helium atomic number 2, neon 10, argon 18, krypton 36, xenon 54, radon 86. The configuration is 2. The configuration is 2-8. The configuration of argon is 2-8-8. The configuration of krypton is 2-8-18-8. The configuration of xenon is 2-8-18-18-8. And the configuration of radon is 2-8-18-32-18-8. These atoms have 8 electrons in their outermost orbit except helium. These are stable atoms as they have the maximum number of electrons in their outermost orbit, and that's why these atoms are chemically inert. Agree? Now, any atom combines with another atom to achieve its stability by gaining the electronic configuration of the nearest inert gas. So the next topic is chemical bond. Chemical bond is simply the chemical force of attraction which holds 2 atoms together in a molecule. This force is developed due to the either transfer of electrons between the atoms or by sharing of electrons between the atoms. Any atom combines with another atom to get this stability by gaining, losing or sharing of electrons with another atom. So chemical bond is of three types. One is ionic bond, or this is also known as electrovalent bond. The second is covalent bond, and the third is coordinate or dative bond. Further, covalent bond is of two types: polar covalent bond, and the second is non-polar covalent bond. Non-polar covalent bond. There are three types of bond: ionic bond, covalent bond, and coordinate bond. Now we will discuss all these bonds individually. Now the first type of chemical bond is ionic bond. Ionic bond. This is a chemical bond which is formed between two atoms due to the complete transfer of electrons between them. Suppose we are talking about NaCl, sodium chloride molecule. NaCl molecule. NaCl comprises of two atoms, Na, sodium atom, and chlorine atom. Sodium has one electron in its outermost orbit. The configuration is 281. Chlorine has 7 electrons in its outermost orbit. The configuration is 287. Both are unstable. Sodium is a metal and has the tendency to lose electron. Chlorine is a non-metal and has a tendency to gain electron. Sodium loses one electron to chlorine atom to form Na plus, and chlorine gains one electron from sodium atom to form Cl minus. After losing one electron, the configuration of sodium becomes 28, and by gaining of one electron, the configuration of chlorine becomes 288. Now the both becomes stable. This is the electronic configuration of neon, and this is the electronic configuration of argon. In gaining this stability, sodium loses one electron and becomes positively charged. Chlorine gains one electron and becomes negatively charged. Now these two oppositely charged ions attract each other with an electrostatic force of attraction and aggregated together to form Na plus Cl minus, or simply NaCl. So ionic bond can simply be defined as the electrostatic force of attraction between the oppositely charged ions. Agree? So we can conclude that a chemical bond between the atoms of a metal and a non-metal is ionic bond. Now we are talking about the calcium oxide molecule. Calcium has 2 electrons in its outermost orbit and the configuration is 2882. Oxygen has 6 electrons in its outermost orbit and the configuration is 26. Initially both are unstable. as it has only 2 electrons in its outermost orbit and it has 6 electrons in its outermost orbit. It is a metal, it is a non-metal. Calcium loses 2 electrons to oxygen atom. By losing 2 electrons, calcium atom forms Ca++ ions and oxygen atoms form oxygen minus ions. By losing 2 electrons, the electronic configuration of calcium becomes 2 8 8 and of oxygen it becomes 2 8. Now these both are stable. These both have a stable electronic configuration. In gaining this stability, calcium loses 2 electrons and becomes doubly charged calcium ion, and oxygen gains 2 electrons and becomes oxide ion. Now these two oppositely charged ions attract each other with a force of attraction and get aggregated to form CaO or simply CaO. This was ionic bond. So ionic bond is simply the electrostatic force of attraction between the oppositely charged ions. Agreed? Now, the compound which is formed due to the ionic bond is the ionic compound. Now, we are talking about the covalent bond. Covalent bond. It is a chemical bond which is formed due to the mutual sharing of electrons between two atoms. Suppose we are talking about the oxygen molecule, O2 molecule. Oxygen atom has atomic number 8 and the configuration is 2 6. So oxygen has only 6 electrons in its outermost orbit. It will require 2 electrons more for its stability. So two oxygen atoms, both these oxygen atoms have the tendency to gain electron, no one in the position to lose electron. This atom has 6 electrons in its outermost orbit. 2, 3, 4, 5, 6. This atom has 6 electrons in its outermost orbit. Now, there is the mutual sharing of 2 pairs of electrons between these two atoms, and by sharing these electrons, both the atoms become stable. Now, this atom has 8 electron. This atom has 8 electron in its outermost orbit, and these two atoms get aggregated together as O2 molecule with double covalent bond between them. Agreed? So this is the covalent bond, and the molecule thus formed is the covalent molecule. If we are talking about the chlorine molecule, Cl2 molecule, chlorine has atomic number 17, the configuration is 287. So it will require one more electron to become stable. Chlorine has 1, 2, 3, 4, 5, 6, 7 electrons in its outermost orbit. Another chlorine atom has 1, 2, 3, 4, 5, 6, 7 electrons in its outermost orbit. Now, both the atoms will share one pair of electrons between them, and both the atoms will become stable, and this is Cl single bond Cl, or this is Cl2 molecule. Cl2 molecule. This is covalent molecule. Now we are talking about the HCl molecule. HCl molecule. In HCl molecule, hydrogen has only 1 electron in its outermost orbit, and chlorine has 7 electrons in its outermost orbit. So both these atoms will share 1 electron each, and there is the mutual sharing of one pair of electrons between these two combining atoms, and there will be single covalent bond between the hydrogen and chlorine atom to form HCl molecule. Here HCl is the covalent compound. Agreed? Now we are talking about the N2 molecule, nitrogen molecule. Nitrogen has atomic number 7. The configuration is 2,5. So nitrogen has only 5 electrons in its outermost orbit. It will require 3 more electrons to become stable. So 2 nitrogen atoms will have the mutual sharing of 3 pairs of electrons between them, and there is triple covalent bond between 2 nitrogen atoms, and the molecule is N2. This molecule is covalent molecule. Agreed? Now we are talking about the methane CH4 molecule. Carbon has atomic number 6. The electronic configuration is 2,4. Hydrogen has atomic number 1. The electronic configuration is 1. So it will require 4 more electrons to become stable, and it will require 1 more electron to become stable. Both are non-metal, so both have the tendency to gain electron. No one in the position to lose the electron. So these two types of atoms will have the mutual sharing of electrons between them. So carbon has 1, 2, 3, 4 electrons. Hydrogen has 1 electron. Hydrogen has 1 electron. Hydrogen has 1 electron. Hydrogen has 1 electron. Carbon combines with all these hydrogen atoms by single covalent bond, and all the atoms become stable with the electrons in their outermost orbit. Carbon has now 2, 2, 2 and 2. 8 electrons in its outermost orbit, and hydrogen has 2 electrons, hydrogen has 2 electrons, hydrogen has 2 electrons, hydrogen has 2 electrons. So carbon single bond H, single bond H, single bond H, single bond H. Or this is CH4 molecule. This molecule is the covalent molecule, and methane CH4, methane is the covalent compound. Agreed? Now there are 2 types of covalent bond: polar covalent bond and non-polar covalent bond. So first is polar covalent bond. It is clear that covalent bond is always formed between the atoms of non-metals, and non-metals are electronegative elements. Different non-metals have different electronegativities, that is, they have different tendencies to gain electrons. Someone is with higher electronegativity, someone with lower electronegativity. So polar covalent bond is the covalent bond which is formed between the atoms of different electronegativities. Just see the example, the formation of HCl molecule. In HCl molecule, there are 2 types of atoms. One is hydrogen atom, one is chlorine atom. Hydrogen is less electronegative than that of chlorine. So in comparison, hydrogen is slightly positive than chlorine. So in between hydrogen and chlorine, there is the mutual sharing of 1 pair of electrons, but chlorine is more electronegative, so the shared pair of electrons will not lie exactly in the mid of these 2 combining atoms. The shared pair of electrons will slightly shifted towards the chlorine atom, and due to this shifting, Due to this shifting, hydrogen will acquire slight positive charge and chlorine atom will acquire slight negative charge. But there is the mutual sharing of electrons of one pair of electrons. This bond is like this, as single bond Cl H delta plus Cl delta minus, and the molecule is HCl. So the covalent bond between the atoms of different electronegativities is the polar covalent bond, and the compound is the polar covalent compound. Now, second is non-polar covalent bond. It is a covalent bond which is formed between the atoms of same element or different element having equal or almost equal electronegativities. Suppose we are talking about the Cl2 molecule. Cl2 molecule. In this molecule, both the atoms will have equal electronegativities. So, the shared pair of electron will exactly lie in the mid of the combining atoms, and no charge gets developed on any of the atom, and the molecule is Cl single bond Cl or Cl2. This covalent bond is the non-polar covalent bond. Now, we are talking about the CH4 or methane molecule. CH4 or methane molecule. Carbon and hydrogen atoms are the atoms of different electronegativities. Carbon and hydrogen are the atoms of different elements, but they have almost equal electronegativities. So, in CH4 molecule, the shared pair of electron lie exactly in between the combining atoms, and no charge develops on any of the atom, and the molecule is like this: C single bond H, single bond H, single bond H, single bond H, or simply CH4 molecule. So this molecule is non-covalent molecule, and the compound is non-polar covalent molecule, and the compound is non-polar covalent compound. Agree? Now we are talking about the coordinate or dative bond. Coordinate or dative bond. It is a chemical bond which is formed due to the one-sided sharing of electrons pair between two atoms. Suppose we are talking about the O3 ozone molecule. In ozone molecule, there are 3 atoms of oxygen atoms. So oxygen having 6 electrons in its outermost orbit. This oxygen atom will have 6 electrons in its outermost orbit, and the third oxygen atom will also have 6 electrons in its outermost orbit. There is the mutual sharing of electrons pair between these two atoms, and one-sided sharing of electrons pair between these two atoms. Like this. In this structure, these two atoms have the mutual sharing of 2 pairs of electrons between them, and there is one-sided sharing of electron pair between these two atoms. This atom is sharing with the electrons pair of this atom. This is called the acceptor atom, and this is called the donor atom, and it is finally written as O double bond O coordinate bond O. Means coordinate bond is denoted by an arrow sign pointing towards the acceptor atom. This is acceptor atom. And this is donor atom. Donor atom. Coordinate bond is always formed with the covalent bond. It has not the independent existence. See the second example. Sulfur dioxide molecule, SO2 molecule. Sulfur has 6 electrons in its outermost orbit. Oxygen has 6 electrons in its outermost orbit. Oxygen has 6 electrons in its outermost orbit. There is a mutual sharing of 2 pairs of electrons between this atom and this sulfur atom, like this, and one-sided sharing of electrons pair between sulfur and this oxygen atom. Here, this oxygen atom is sharing with the electrons pair of this sulfur atom, but this sulfur atom is not sharing with this oxygen atom. And finally, this can be written as O double bond S coordinate bond O. This is the acceptor atom, this is the donor atom. Agree? So these are the basic concepts of chemical bond for secondary classes. In senior classes, you will have to study some advanced points, topics. Now, we have some examples which contains all the different types of chemical bond. Suppose we are talking about the calcium carbonate CaCO3 molecule. In CaCO3 molecule, carbon atom has 4 electrons in its outermost orbit. 1, 2, 3, 4. Oxygen atom has 6 electrons in its outermost orbit. 1, 2, 3, 4, 5, 6. Oxygen atom has 6 electrons in its outermost orbit. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There is the mutual sharing of 2 pairs of electrons between these 2 atoms. Mutual sharing of 1 pair of electrons between this carbon atom and this oxygen atom. And mutual sharing of 1 pair of electrons between this carbon atom and this oxygen atom. And this is like this. Now carbon has 4 to 6 to 8 electrons in the outermost orbit. This oxygen atom has 4, 8 electrons in the outermost orbit. But this oxygen atom has 2, 5, 7 electrons in the outermost orbit, and this also has 7 electrons in its outermost orbit after combination. Calcium has 2 electrons in its outermost orbit. This calcium will provide 1 electron to this atom and 1 electron to this atom. By losing 2 electrons, calcium will form Ca++ ion, and by gaining these 2 electrons, the whole radical becomes like this: C double bond O, single bond O, single bond O, O 1 unit negative charge, this oxygen atom 1 unit negative charge. Or finally, you can say is Ca2+ and CO3 2 minus. 1 minus, 1 minus is 2 minus negative charge. Now these two oppositely charged ions will attract each other and form CaCO3. So this molecule has both the covalent bond and the ionic bond. But finally the compound is ionic compound. Agree?